Okay, so we're doing some homework together here, sum, difference, and double angle identities homework from 6.2. I've got on the right side here, I've got the identities, and you can see those here on the right. So let's take a look at question number 1 for those of you having trouble getting started or just want to see how I do number 1. It says this: write each expression as a single trig function. So what we're trying to do is recognize these patterns here as either sums or differences, or in some cases double angle identities or whatever. So it's pretty easy at the beginning. You're looking for this pattern: cos A cos B minus sine A sine B. Okay, so where does that fall? Where do you see that? Well, cos cos sine sine. Look at this. Oh, is it plus or minus? Not minus. Oh, it's plus. Okay, so I see it right here, right? Cos A cos B. Oh, no, it is minus. Minus. Cos A cos B minus sine A sine B. So this is it right here. So what that means is we can rewrite this cos of A plus B. So for A, this is actually cos of 43 plus 27, because this is a minus and here's the minus here. So it's plus. So that is cos of, what's that, 60, 70. Cos of 70. Okay, that's A. B, okay, this is sine cos plus cosine. Sine cos plus, oh, here we go. Sine cos plus cosine. So that's a sum as well. So the angles that I see here, 15 and 20, I have to add them. So for B, we've got, and that's a sine, so we've got sine of 15 plus 20, or sine of 35 degrees. Okay. All right, what about C? Okay, so C, where do I recognize this pattern? I'm going to change my color here. C, okay, so I've got cos squared minus sine squared. Oh, okay, I look over here and I see, here we go, cos squared minus sine squared. That's the same as cos of 2a. What's my angle? 19. So it's the same as cos of 2 times 19, or cos 38 degrees. All right, so you're simply looking at the pattern and comparing it with our stated identities that we learned today. Okay. All right, D and E get a little tougher, so let's take a look at D and E. Sine cos minus cosine. Okay, sine cos minus cosine looks like up here. So we've got sine of A minus B. Okay, so for D, I've got when I say sine of A minus B, yeah, right here. Sine of, now A is going to be 3 pi over 2 minus B is 5 pi over 4. So that's going to be sine of, now we should get these with a common denominator, right? So that's going to be 6 pi over 4 over here. So 6 pi minus 5 pi is 1 pi over 4. And that's the answer there. Okay. Sine of pi over 4. Now, sine of pi over 4 is pretty straightforward. This looks pretty complicated, doesn't it? Okay. Now, arguably the trickiest one here, I think, looks like E, because this doesn't look like anything, really, I don't think, that we have on our chart here. But what is it close to? What is it closest to? A number times sine of something times cos of the same thing. Okay, a number times, oh, here we go, look at this. That's close, although this isn't the 2, that's a 2 there, this is an 8. Okay, so we got a little bit of work to do here, and I'm now going to erase my work from the first few so I have a little space here to work. But what we're going to do is we're going to try and get it into this pattern here. I want to get it so it looks like this somehow. So 8, I'm going to rewrite this, 8 sine pi over 3 times cos of pi over 3. I'm going to write it like this. I'm going to make this a 4 times 2 sine pi over 3 cos pi over 3. See that? So now it's still the same, but I have this inner part here that is exactly the same as this. So this can actually be written as 4 times sine of what? 2 times this value. So what's 2 times pi over 3? Well, it's just 2 pi over 3. That's as simple as you can get. So, right, as a single trig function, that's a single trig function. That's your answer. It's just 4 times sine of 2 pi over 3. All right, so that's the trickiest probably part of number 1 there. If any of my online class has questions, please chat in about that. I'm going to move on to the next one if I don't see any questions. All right, let's move on to number 2 then. Simplify and give an exact value for each expression. Okay, so we have cos minus sine. Again, I'm going to bring this down here so we can have this on the same screen. Okay, cos sine. So where's cos minus sine? Cos, oh, here we go. Cos minus sine. That's going to be cos of a plus b. So a is going to be cos of 60. Now it says simplify and then give an exact value. So that's why I have the unit circle up here. We're going to refer to that unit circle. I guess I can't move that over too far. So cos 60 are special angle triangles you could think back to, or you could use the unit circle. Cos of 60 is the first value here in the coordinate for the angle 60, so that's 1/2, right? 1/2. And yes, 1/2 is an exact value. It's a fraction. Okay, it's not a decimal. Even if it was a decimal, it's a terminating decimal, so that's exact. Okay, if you wrote 0.5, even though it's a decimal, you're going to say, oh, that's approximate. Well, 0.5. See, if it terminates or repeats, it actually can be written as a fraction. So that is exact. All right, just to be safe, write it as a fraction, though, to be safe. Okay, what about B? Sine, cos, plus cosine. Notice I'm going to look at the pattern first. Sine, cos, plus cosine. Where do I see that? Sine, cos, plus cosine. Oh, I'm close. Sine, cos, plus cosine. Here we go. Right here. So this is going to be sine of the sum of these two angles. Awesome. So that's sine of 45. Ooh, hey, sine of 45. I can see that right here. It's root 2 over 2. Root 2 over 2. Yay. Got it. Okay. C. Let's go on to C here. Cos squared minus sine squared. Notice I'm looking at the pattern first. Where do I see the pattern? I think I have to move this up a bit. Cos squared minus sine squared. Ah, right here. Cos of 2a. Now you may have thought about that before we looked here, okay? Because we've seen this a couple times now. So memorize that, right? Cos 2a. Cos 2a. So cos of 2 times pi over 6. Cos of 2 times pi over 6. Which is the same as cos of what? 2 pi over 6 or 1 pi over 3. Ah, awesome. Pi over 3, cos 1/2. Okay. Got it? And D, cos minus sine. Where is it? Cos minus sine right here. So that's cos of A plus B. So D is cos of pi over 2 plus pi over 3, right? Cos minus sine is a sum. So that is going to be, what is this here? That's cos of, well, we're going to have to get a common denominator, so that's going to be 3 pi over 6 plus 2 pi over 6. That's going to be 5 pi over 6. And on my unit circle, I see 5 pi over 6, and the cos is the first one, so it's negative root 3 over 2. Negative root 3 over 2. That's question number 2 in your homework. Okay, so here's number 4 then. Again, write each expression as a single trig function. So again, we're just looking at our patterns here. So what do I see? I see 2 sine cos. 2 sine cos right here. That's sine of 2a. What is a? Pi over 4. So that's sine of 2 times pi over 4. What's 2 pi over 4? Well, that's sine of pi over 2. Okay? Single trig function, you don't have to evaluate it. Alright, I'm not sure if I'm liking that red. B. Ooh, this one looks tough. Wow. I don't see that anywhere on here. This is getting tough now, isn't it? So 6 cos squared minus 6 sine squared. Okay, okay. Do you know what I see first? I see roughly I have a pattern cos squared minus sine squared. Now I know that that's over here. But it doesn't look quite the same because I got the 6 here. But I have a 6 in each term, so you know what that means? That means that I can factor a 6 out perhaps. So let's try that. If I take a 6 out of this expression, I get cos squared of 24 minus sine squared of 24. Times tan of 48. Oh, okay, I'm going to have to do some work with tan of 48 as well. Now, tan of 48, oh, you should be saying, 24 is half of 48. So look at this. I could write tan of 48 in terms of tan of 24. And I think that's going to really help us simplify things. So let's do that next. Can I simplify this as well at the same step? I think so. So 6, now what is this one? This is cos squared minus sine squared. That's going to be cos of 2 times 24. Oh, well actually, do you know what? Maybe I'll do that first instead of rewriting tan of 48, because I can actually write this as cos of 48. Cool, good thing we did that in the same step. Saved us a little bit of work. Okay, see what I'm saying? Okay, so now I've got my trig functions in terms of the same angle. So guys, remember, if I had cos of theta times tan of theta, you know what to do. You simplify the tan of theta as sine theta over cos theta. Don't forget that this theta can be any acceptable angle, right? Any angle that's mathematically permissible, including a 48. Okay? So I know this looks different, and I've had students before saying, oh, but I know what to do with theta, but I don't know what to do with 48. Well, theta represents any angle which could be 48. So you do all the same stuff. All right. So I'm going to have a 6 here, and I'm going to do this right here. And look at what happens over here. Cos and cos. So let's say this is 48. 48 and 48. So when I multiply these two, I see over here that I'm left with sine of 48. And that is in terms of a single trig function which they're asking for. So that looks like I'm done there. Okay. So now they're getting a little more complicated. Okay, true. Let's move to C. Maybe I'll do C over here, make some space. So C says 2 tan 76 over 1 minus tan squared. Okay. Does that ring true? You know what? That looks like this over here. Okay. That looks very similar. Is it pretty much exactly the same? 2 tan theta, or 2 tan A over 1 minus tan squared. Yeah, it's exact same thing. So C, you don't have to do much work here, it doesn't look like. If this is A, so 76 is A, I can write this as tan of 2A, or 2 times 76. So what's that? Tan of 152? Tan of, 152 degrees. Okay, should we check that? Let's just check our work here. All right, everything's working out here so far. All the answers so far we've done are absolutely correct. Everything's on board. Let's do D here now. So 2 cos A minus 1. Do I see that anywhere? Yep, right here. 2 cos A minus 1. So that means that whatever A is, I can write this as cos of 2 times whatever I see. What do I see? Pi over 6. So that's cos of 2 pi over 6. And what does that equal? That's cos of pi over 3. All right. And finally, E. Again, these last couple sometimes get a little tricky. E might be a little tricky. Do I see this 1 minus 2 cos A? 1 minus 2 cos A. 1 minus 2, sine A. 1 minus 2 sine A. That's too bad. Close. Oh, but look. This is very similar to the one we just used. Very similar. It's not the same, though. So if you have 2 cos squared A minus 1, that's not the same as 1 minus 2 cos squared A, but it's very similar. And how similar is it? Well, if I factored a negative 1 out of there, what would I have? Well, this 1 would change sign, that would change sign, and I would have this. And notice, now this, once I've factored -1 out, that's simply this right here, -1. And that is what we're looking for. Okay? So when you have the terms switched around in a difference, like so 1 minus this, or this minus 1, you factor a -1 out, and then they become the same. So this right here, 2 cos squared theta, or a minus 1, is actually cos of 2a. So this is negative cos of 2 times pi over 12, which is pi over 6. So it's negative cos pi over 6. And there's working for number 4, so please let me know if you have any problems with number 4 there. Okay, I'm going to do one more question for this homework video, and this is from question number 5, which apparently I don't have the instructions. What does it say? Simplify each expression to a single primary trig function. Okay, a single primary. So you know what the primary trig functions are? Sine, cos, and tan. Okay. All right. Well, it looks like we got a little bit of work to do here, because this looks quite complicated. Complicated. Okay, let's bring our identities down here. You're going to want to have those handy, right? It's going to be pretty important here. So let's get back to 100% screen size. All right, key ideas right here. Beauty. Somewhere there. There we go. Okay, so I might need to use several trig identities here to manipulate this. Okay, now remember, we can't just go ahead and multiply the top by something or add something in there from just out of thin air. You can multiply the top and the bottom by the same thing. You can't add or subtract the top and the bottom by the same thing. That's not the same. Only multiplying and dividing the top and the bottom by the same thing is possible. But I don't know if we're going to need to do that, because look at what we have here. I have cos cubed. Well, and again, I don't know. There's different ways you could attack this, okay? But what I see is I see a couple things. I see that there's a cos squared times cos here. So I could pull a cos squared out. What's up with cos squared? Well, I see cos squareds in different places here. I certainly don't see any cos cubes, so this has to be changed. I see a cos of 2x. Oh, okay. So cos of 2x, I have lots of options for cos of 2x. I have these 3, so that's going to be great. And as a matter of fact, I see cos squared minus sine squared is really sticking out to me, because I have cos squared minus sine squared plus sine squared. Ooh, the sine squareds are going to go. Let's do that. So I'm going to do this cos squared x times cos x, just because I like squareds better than cubes. I don't see any cubes in there. And then this cos of 2x, I'd like to use this one, because I see that negative sine squared a, and that's going to be a plus sine squared a. Those are going to cancel each other out. So let's see. Cos squared x minus sine squared x, and don't forget this part, plus sine squared x. Okay, so now I can go ahead and I can simplify. What can I simplify? Well, instead of, now don't do this first, okay? Don't do this first when you have subtractions and stuff on there. Just don't get into the habit. Do the simplify the subtractions first. What I mean is negative sine squared plus sine squared give you 0. So that's like cos squared plus 0 now on the bottom. All right, so you have cos squared x times cos x, and what's left on the bottom is the cos squared x. Now you can see, okay? Now you can see what's happening. I have 2 factors up top and 1 factor on the bottom, so this divides out with this. You can't do that when there's adding and subtracting. In this case, it would have worked because these cancel each other out. It's like they're not there. But normally, you can't take one of these with one of this if it's subtracted by something else. Okay? Normally, can't do that. It has to be factors, multiplication factors. So here, now, I've just simplified this to cos x. Beauty. That's a single primary trig function. And this, I know this is 6.2, but in 6.3, this is what we're going to focus on. Right there. rewriting a complicated expression, taking pieces, rewriting it using the identities that you see on the screen there, and then we're going to change it so that it looks like something else. And that's going to be the prime goal going forward. Okay, so there's your homework for 6.2. There might be other questions. Look on my website, www.mrmathwell.com, for other videos, instructions, and resources, and all sorts of fun stuff. Okay, so that's the homework for your 6.2.